So one part of that is understanding what the independent and dependent variables are. So identify, we just want to figure out what these independent and dependent variables are in this experiment, and of course that can map to other experiments. So the independent variable is the one that we can change as a scientist. So if I wanted to see how much time it takes to boil different amounts of water, I could try and boil 1 kilo of water, 200 grams of water, and then 1 gram of water. You can see I can change that amount of water, however I want. So that is the independent variable, because I can change it. Because I am the scientist here, and I can change each of those things. So what can we change? Well, it doesn't really become immediately apparent what we can change in this one, but the one that we can change is the sand, salt, and water mixture. We could go to one beach and collect a sample. We could go to another beach and collect a sample. And that is the independent variable. The independent variable is the mixture itself. That is what the independent variable is. Because I can change it, I could go to different places and get different mixtures if I wanted to. Dependent variable is the one that changes based on the independent variable. For instance, when I boiled all those different amounts of water, the dependent variable is how much time it takes. Because obviously 1 kilo of water will take longer to boil than half a kilo of water. So you can see that the dependent variable relies on the independent variable. If the independent variable is the mixture, then the dependent variable will be how much sand, salt, and water we get out. So if I went to a very, very salt, like say a beach in the Dead Sea, and I scooped up some sand, I would expect a lot of salt. But if I went to a freshwater river, I would expect no salt. So you can see that if I just pick those two different places as a scientist, the amount of salt changes instantaneously. The amount of salt I measure will be different. You can see that the amount of salt depends on the mixture that I pick. And that's why it's called the dependent variable. So that's important to understand, particularly when you want to design experiments. So why is the crucible more preferable to filter paper during the drying process? So I mentioned this. So the filtering crucible is not absorbent. Okay, so this is basically what this says. Filter papers are absorbent. Absorbent meaning they absorb water in this case. So because the filter paper may absorb some water from the atmosphere or from the, say, humidity of the device, it could throw off our measurements because we would be adding a little bit of water mass to our filter paper sand mass. So we'll get wrong results. The crucible doesn't absorb water. We can just ignore that error. It's not going to exist. So that's why it could be beneficial to use the crucible. So other than the drying phase, what are some sources of error in this investigation? Again, we're thinking about, first question was about what are the variables? Second question was about what are some ways to improve the experiment? And this one is saying, well, even if we can't improve the experiment, we want to know where there is error. Error exists, and that's something we deal with. So the question is, as long as we can identify it, we can try and minimize it as much as possible, but it's not going to disappear. So that's really important when you design experiments. One may be that the salt may be left on the sand because we didn't wash it well. There's no, for instance, a universal standard on washing. That's just one problem. We have to deal with the fact that not everyone is going to be able to wash perfectly the sand, and that's a source of error. And again, someone might get a little bit over-enthusiastic about the boiling process. Salt splatter is another source of error. This one we can reduce a lot because we just say, look, don't splatter the salt. But this one is a little bit harder because it's not always immediately apparent how clean the sand needs to be. That's just something to think about. Well, this one we can get rid of. This one is a little bit more difficult to completely ignore. Just two sources of error that have different ways of dealing with them. Discuss the need for safety precautions while carrying out this experiment. Safety, of course, is important. We don't want anyone hurting themselves. From what you can see, it's pretty safe, this experiment. Nothing super dangerous that we're doing. If you go to the beach, it's as dangerous as this experiment, I guess. For instance, glass, I would expect that, well, don't break glass, obviously, that's one danger, but that kind of is so much common sense that we'll just ignore it because we expect that you don't break the glass. The real risk here is burning yourself. Obviously, again, that seems like common sense, but there is an element of risk when you are boiling or heating things, and burns are particularly nasty, right? You just have to be aware to avoid burns because that is just one risk of this experiment. About making the experiment better. Being able to look at an experiment and say, well, we could do this better. Describe one procedure which can improve the accuracy of gravimetric analysis experiments. Okay, so this particular one, how can we make it better? So we can improve the accuracy by ensuring the mixture has been dehydrated until constant mass has been achieved. So again, constant mass, that's a really important one. We want to make sure all the water is gone. That is one way to really improve the accuracy of this experiment. You could do sort of like a staged heating process. So we've got to heat it once, then weigh it, then heat it again, then weigh it and make sure that they're the same. That is to ensure that there's absolutely no water left in it. For instance, a single heating step may not be sufficient to remove all the water. Now you might think, oh, if you've got like a block of sand and you heat it, it might be the case that the outer sand insulates the inner part. While the outside might be quite hot, the inside might be still very cool. For instance, if you look at a desert, there are lots of creatures that live under the surface, and there's lots of moisture there. You'd think a desert is very dry. Sand gets belted with sun all the time, yet creatures can survive a couple of meters under the sand, I guess. You just have to make sure that by heating it several times, we are making sure that all of that energy gets into the sand and into the water. We omit any additional air from the water. We could just heat it a couple of times. So that concludes today's lesson on gravimetric analysis. We looked at how to perform gravimetric analysis for a very simple experiment, and then we looked at some ways to improve it, and also looked at what are some features of this experiment. So hopefully you can take some of the concepts here and apply them to different experiments, and that will help you to understand analysis in general and the scientific method as a whole. So thank you, and I hope you've enjoyed this lesson.